Ready? Okay. Can I have your attention? So, two things I want us to be able to do quickly. They are related. One of them is the division of the polynomial, and the other is the remainders theorem. But the remainders theorem will then lead us to factors theorem by tomorrow. Part of tomorrow's class will be used on that. Now the division of polynomial is just like division of numbers. So for example, if you have back in our elementary school days, if you have 3 here and you have maybe 4, 15, I don't want plus 9, let's say plus 2, that's 11, so there'll be a remainder. Okay. So if you have this back in the elementary school days, what is the first thing we always do? Elementary division, come on. What is the first thing?
Divide the first number by the...
You look at the first one, right?
Yeah.
So that's 1, right? Then what do you do?
You write 3 at the bottom.
Where do you get that from?
No, because you 3 times 1. You subtract it, right?
Subtract what?
From the first one.
What do I subtract exactly?
3 from the 4.
So 4 minus 3 like that.
No, like you write 3 at the bottom.
So what I'm asking you, how do you get a 3 at the bottom? And you said I subtract.
3 times 1.
Exactly. You haven't mentioned the times.
Oh, okay.
So you multiply, then you subtract. And you get what?
15. 1, sorry.
4 minus 3 is 15?
Yeah,
Hallelujah. Then what is it? You see, there's a reason I'm asking you to speak like you're in kindy. Because you don't want it to be confusing when I start dealing with functions. So you telling me 15 is like you just going beyond your boundary for now. That's not what I'm asking you. There's a reason I'm asking every silly question. There's a reason. So what do we do next?
You move the 5 down.
You move the 5 down. I need you to listen to everything you are saying. And once you move the 5 down, what do you say?
You multiply 3 again to 5.
So 3 times 15.
3 times
3 times 5.
Where does the 5 come from?
You need to divide.
You find the
15.
Did
closest.
you hear yourself?
Yes.
Was that the next step?
No.
Divide,
What's the first next step?
divide 15 by 3.
You need to divide again. See how many times can you get 3 from here? And that is 5. Then what do you do next?
3 times 5.
Then you multiply back. Then what do you do?
Subtract.
You subtract.
Get 0.
Do you remember
Get
this,
0.
mister? You need to be part of this conversation. Then you get 0. And what do you do next?
And then move the 2
You
down.
move the 2 down. Okay? Then what do you say?
You divide 2 by 3, and you find out that you can't do it, so you put a 0.
Thank you.
Now
Then
0 times 3,
You multiply,
you get there, and then
Take your remainder.
you minus,
and there's nothing to be done again. Then what do you call this?
The remainder.
A remainder. What is this called?
The
We never got a name then, I
dividend?
understand. No.
No, it's not. Okay.
This is the quotient.
Oh, okay.
Quotient. Okay? This is the remainder. This is what? The divisor. And this is the dividend. Okay? So this is called divisor. This is the remainder. This is the quotient. And this is the dividend. So those are the 4 key things to know. So the process will be similar if you are dealing with a polynomial. Your polynomial will be the dividend. So let's say the polynomial is p of x. Okay? And you have a divisor, d of x. after the process, there will be a remainder, r, or r of x sometimes. But most of the time it will be a constant. I'll tell you when. Then there will be a quotient, maybe q of x. So at the end, you will realize that your polynomial, can you tell me a relationship between d, q, r, and p? One relationship.
dx times
Speak louder, please.
dx times qx plus rx equals to p.
That's it. This times this plus this gives you that back. Okay? So that the polynomial is simply the quotient times divisor plus the remainder. Does that make sense? So our division algorithm is similar to this, and that's what we want to quickly do. So, so please write. The division algorithm well, I think it's a repetition of what I said here. So maybe we just take an example. Divide 2x. No, x squared. Plus 2x minus 3 by x plus 2. Please pay attention. Again, you put your divisor here, you put your dividend in here. Just like you did this one by one, you did this also term by term. You must arrange both of them in descending powers of x. So highest power comes first in both of them. Regardless of how the question is given, you must first achieve that. If some terms are missing, you leave the space by using coefficient 0. Just like we did in multiplication, remember? You put this 0x squared somewhere because you're going to need it later. That is very important also. So, you go with the, but the only difference here is you don't, just like, oh, how many 3 can you get in 1? You don't say that in polynomial. You don't say how many x plus 2 can you get in x squared. You consider the higher power and the higher power each step. So for example, how many x can I get from x squared? It's more or less dividing, like x squared divided by x.
2x.
Okay? What? X squared divided by x.
Oh, that's
That's x. So this will be x. But when you multiply by both of them and write in the appropriate places. So that will be x squared plus 2x. And when you subtract, you get negative 3. Normally you will say, how many x can you get in this? You can't divide anymore. You stop when the degree of the remainder is strictly less than the degree of the divisor. If the degree are still the same, you continue. So this is quadratic and this is linear. This is a constant. Constant is even below linear. So this is the end. So it means your quotient is x and your remainder is negative 3. Okay? In your book, if the question was, oh, write in the form of, but the question was actually given as this. X squared plus 2x minus 3 divided by x minus x plus 2. You have to write in the form of a mixed fraction. So it is simply x whole number in quotes minus 3 divided by x plus 2. Because if you are given this, in this case, you would have said this is what? You would have said this is 150 whole number, 2 over 3, isn't it?
Yeah.
That's exactly what this is. It is the quotient whole number, remainder divided by the divisor. So similarly, quotient whole number in quotes, remainder divided by divisor. Remainder is minus 3, that's why I put a negative in between. If it is not, you put a plus in between. Remember, you can't write the function and say x, no space, x over. It doesn't make sense. That's why we write this way. And this is what you need for your other rational function. That's why we're taking this topic first. So if the question is about expressing in this form, this is how you conclude. If it is just to divide, you just divide and you say, oh, your quotient, you state the quotient. Quotient is x, remainder is negative 3. That's it. Understand? Please write. So let's take more interesting stuff. Kelly is running away from the boys today. What did you guys do to her? Stole her food, maybe? Yeah. She doesn't joke with food. If you steal her food, she runs away from you. She loves food. Take the last two. Maybe one from here. 2x squared. 2x to the power 4. Guys, let's look up this. Let's look up and do this together. You have 2x plus 3 as your divisor, and your dividend, 2x to the power 4, x cubed, x squared, x term, and the constant. All arranged, nothing is missing. So the first one gives what?
X cubed.
X cubed. I need everyone's contribution. We divide this by the first one. First divided by the first one. Okay?
Yep.
Alright. So when you multiply back, what do we get?
2x to the power 4
plus
plus
3x cubed. Then we subtract. If I didn't put subtract here, this always put it in a small bracket. It's just so you know what is happening. So you don't subtract the first one, gone.
Gone.
Subtract the second one,
Negative 4x cubed.
negative 4x cubed. Then you bring down the next one. Sometimes the next one is not useful. Maybe this is the next one is a 0. And when you do the next operation, you are going to end up getting an x term. Then you can now bring it down if it is needed. But always bring down the first one only to make your work neat. So again, the first one on the first one, what do you get?
Negative 2x squared.
Negative 2x squared. Yanko, understood?
Yeah.
So multiply back negative 2x squared, please, not the 2x squared only. So what do you get?
Negative 4x cubed.
X cubed,
Minus 6x squared.
Good. Then you subtract. You see, I put my minus in the bracket. The first one is minus, minus, minus 0. And this is what?
5x.
5 with a positive, isn't it?
Yeah.
You bring down the next one now. 7x. What do you notice? We're in trouble.
Yeah.
We're not in trouble.
5
5 over 2
negative
x. We're not in trouble. It's not impossible. Try not to use decimal. Okay. Because I know we have decimal babies in this class. So multiply back, right?
Yeah.
And this gives what?
15 over 2.
15 over 2x. Perform our subtraction. It's just trying to scale us. You can do it.
Half.
So that's 7 minus 15 over 2.
Negative
That's negative half.
Yeah.
Very smart. Bring the last one. Okay, now. What is that?
Negative 1 over 4.
Negative
Perfect. Smart. Negative 1 over 4. This is just remember, internal divided by external. So in the case of this one, it is simply 7x, no. I mean for this one. It's from 7x divided by, is it 7x? Where do we get our 5? Oh, it's from here. It's from 5x squared divided by 2x. That's how this came about. That's your 5 over 2x. And this one is as a result of negative 1 over 4, negative 1 over 2x divided by 2x. X cancel. So you have negative 1 over 2 divided by 2, which is negative 1 over 4. Okay? You know we are only dealing with when the x cancel, you know what to do with the coefficient. You can put it in your calculator if you are confused. But you should be able to train your brain to be able to do this too. Alright? But if you are not so sure, just calculator is allowed, right? You do the process, the calculator gives you the difficult part. So we multiply back. Minus 1 over 2x, yes? Multiply back. Minus 3 over 4. So what is this?
19 over 4.
Which is 4 number 3 over 4. Yes, 19 over 4. What I did was 4 plus 3 over 4. And because that's a proper fraction, so that's like 4 number 3 over 4, then you change it back immediately before anybody suspects you. We can't go further. Because this is a constant and this is linear. It's far below now. You see, when we had linear, don't stop here and say, oh, it's not possible, this is 2, this is half. No, you can still go further. Alright? So it says put it in this form. So what would that be? Therefore,
2x to the power of 4.
the polynomial 2x to the power of 4
minus x
minus x cubed
minus x squared
minus x squared
Plus
7x
plus 4
plus 4 is equal to, yes?
2x plus 3. No, wait, no.
Quotient.
Quotient.
No, this could come first also.
Okay.
So let's just write quotient divisor. It could be divisor quotient, doesn't
Okay.
matter.
X cubed
X cubed
So x cubed
minus 2x squared
minus 2x squared
plus 5x
plus 5 over 2
2x
x
minus 1 over
minus
4.
1 over 4.
Oh, 1 over 4.
My bad. My brain is not connecting with my hand.
times 2x plus 3
2x plus 3
plus 19 over 4.
plus 19 over 4. That's it. Okay? I'd like you to try this on your own.
Alright.
You can leave space for this. I like it. What is it?
For over the, or the last.
It says in this form, this is your remainder. Okay? So it means you multiply this by this and add this. That's what we said here. You multiply this by this and add this to get the original number. So please try number B. 2B.
Oh, so Mr. Daniel,
Yes, sir.
when will we ever use that form?
If it says expressed in the form of a mixed fraction,
Okay.
and when we apply it in the next chapter, which is the complex rational function that is not done by the other class.
Okay.
So something like this. If there is need to express this in this form,
Oh, okay.
so it depends on the statement of the problem. Please leave space and focus on 2B. Nelson, could you check that we are focused here?
When we move to the final side, then we have to move it.
Okay. Actually, we don't need this anymore. Or maybe you can leave it. You can leave it. Maybe I want to check what you have done.
Okay. Then I won't show that. Just that.
Yeah, I already did that.
Okay.
Yeah. When I was doing this, I make sure it's focused here so we can have a record of that. So just this, maybe these two parts.
Okay. All three.
All three. I'm waiting because we need to check some stuff first.
That's done. What do you get 12?
7.
I'm wrong, I didn't use you
What we have
7.
at the end, remainder.
Yeah.
Yeah. Then check.
So compare your answers, please.
I'm going to copy. No, I did 2 times 2 is 4. Right?
What did you get first? Was it X? 2. I got 6.
No, I'm not going
I
to
have.
What do you get for the, what's it called?
wait.
You didn't leave the space for 0x.
Yes, I did. That did.
So you got 7, you got 9,
I
you
got
got
7.
I got 7.
Okay, 2 people are getting 7, 3
Three
people
people
getting
are
7.
getting
So
seven.
you're in
I'm
trouble, dude.
Yeah.
Is it that they are all wrong or you're wrong?
She got 7 too.
Okay, you're in trouble.
Those are all wrong. 3 quarters right.
Can you figure out,
Plus.
check step by step?
That x is multiplied by x is negative 2x.
Oh, you put negative here.
Was positive? Oh, whoops. Genius.
Okay, so everybody got that. Nice. I want you to quickly write this. This is the last thing for today. And I want you to evaluate this one by one. So when you copy the first one, work it out. Of course, you use your calculator. Two minutes, please. I want you to get to this point in 2 minutes. Tomorrow we'll do factors theorem and factorization of polynomials. After that we'll talk about zeros and roots. Then sum and products of roots of polynomial. Are you done? Miss small handed brain. When you write number 1, you can do the answer immediately, just 1 line.
Yeah, okay. These are for the questions. I'll copy them later.
I want you to take note of something. After you're done with your starter, I need you to compare with the last 3 questions that we have done so far. And tell me what you notice. So, hurry up. You don't have to go through all this
just go
detail.
through
Just
everything.
write the last answer.
Okay.
It's allowed. Because we are just investigating something, so no need to do time by time. Just put in your calculator, write the final answer. You can show the substitution, but the last answer just write straight away. Are you done? Observations, please. Who has finished? 1, 2, 3. So I'm waiting for L saying, and also guys with no air.
Oh, but there's 2.
No, I said the 2 guys with no
Oh,
air.
I think he's finished.
Finish?
I finished.
Yeah.
But you didn't signify? Did you finish this?
Yeah.
Okay. Alright. So what do you notice? Question 1, what do you get?
Question 1 is the same as the remainder of
What do you get? Minus
negative 3,
which is
yeah.
the remainder here. Here,
19 over
No,
4.
the same thing, right? And here,
7.
7.
which is the remainder you got.
Yeah.
What does that tell you? So my question is this. If I have a polynomial f of x, without dividing, without performing the division algorithm, what will be my remainder if I divide by x plus a?
Oh, if you equate the
I'm not asking you anything that is story related. If I have a polynomial f of x